Very good. So, I'm ready to go. Yep, perfect. I'm ready.
12 minutes for Microsoft starting right now.
Thank you very much. We are really excited to be here on stage again at the Software Quality Tools Challenge. And we decided to go for the Google ProtoBuf library. It's a serialization library created by Google. It's available cross-platform from the smallest IoT device to the largest data center servers. It's essentially serialization protocol. Think of XML, just much smaller and much faster. So don't expect me to analyze an enterprise UI application here on stage. This is a reusable library which is widely used, and therefore the key requirements that we want to take a look at are reliability, performance and size. We want to take a look at three different angles at this presentation. We want to take a look at how the developer sees static code analysis and code analysis in general. We want to take a look at what the software architect is interested in, and we want to take the head of the quality engineer. The developer, of course, wants a tool that is integrated in her development environment. The software architect wants to understand the high-level overview of the quality of the code, and finally the quality engineer would like to track the technical depths and certain quality indicators. And the rest of the presentation will be completely live, no screenshots, no videos, everything live. So let me quickly switch to my Visual Studio here, and the first thing I will show you is how the developer works with these quality tools. You see here in the analyzers area, the developer can add a bunch of static code analyzers. Microsoft brings a lot of them. You can add open source analyzers like the one from SonarQube, and if you are in a larger enterprise, you can add your own analyzers. It's important that not every library, every project is the same, so you can customize the rule set, because some projects might be more mature, some might be not so mature, so you can tailor that to your specific needs depending on the maturity and stability of the project. Once you have added these code analyzers, and I've done that for this project, you get a lot of errors. Of course, you get these errors and warnings also in your build systems, and I could go through them and analyze them, becoming better and better, but because I only have 12 minutes, I looked at a bunch of very specific examples. Let me show you some bugs or features or code smells that we found when analyzing protocol buffers. For instance, here, this piece of code here does not adhere to the best practices according to, in this case, C# code. In this case, it allocates some memory which shouldn't be allocated, and therefore we get a warning. But the point is, the developer does not only see the warning, a shortcut is enough. If I click here and press this shortcut, I can immediately just press enter and the code is fixed. So Visual Studio does not only come with warnings, but it comes with hundreds and hundreds and hundreds of fixes. Let me show you other examples here. Let's go back from full screen. For instance, here, we have found a bug in the protocol buffers library, as you can see it here. I hope you can see it from the back too. You have OR operators here, but in this case we have a binary OR operator, which is a performance issue. A slight one, but it is a performance issue. This is a bug, and the static code analysis found this bug, and we should definitely fix it. Or let's take a look at this example here. These two lines of code, if you are a developer, and we are now having the hat of the developer on our head, this is not modern C# code. This is C# code as you have written it maybe 2 years ago, but now you have something different. You have so-called pattern matching. The static code analysis tells us that this is not adhering to the latest C# coding practices, so we can just press enter and the code fix will restructure the code and make this code adhere to the latest C# coding practices. As the developer, this is already a lot of value for us, but of course, static code analysis is not everything. Sometimes we have to write our own tests, and I mean, I guess you believe me that we can run tests here in Visual Studio. But the point is, for the developer, we have something special. We can go here into test, and we can run so-called live unit testing. What does live unit testing mean? Let me show you that with a concrete example. I will open up some code here, and live unit testing means that, watch here, on the left-hand side, I immediately get code coverage information while typing code. So we have a line here which is not covered by unit testing code, but this line is covered by unit testing code, and now I'm going to develop something which is not a good idea. I'm changing the plus to minus, so I'm breaking the code. Watch what's going to happen. I'm not touching the keyboard. Live unit testing is automatically detecting the tests which run over over this code, they are rerunning the tests, and now I get informed, hey, I just broke the build. Therefore, I can apply a fix, which is in this case pretty simple because I only have 12 minutes, and in a few seconds, live unit testing will tell me again, okay, here we are, this test is again fixed. So that was live unit testing. Now let's switch gears. Now we are no longer the developer who is focused on the details. Now we are the software architects who wants to get a broader understanding of the software and the software quality and architectural things. So what we can apply here, for instance, here is the so-called code map. For instance, I would like to analyze a little bit deeper the Google ProtoBuf and ProtoBuf library, and inside this library, let me do some filtering, because in this case I'm primarily interested in, what am I interested in? The inheritance stuff. So which classes inheritance which other classes? And in this case I see that the root namespace Google ProtoBuf is used by collections, and I would like as a software architect to understand how these areas of my software work together, which abstractions are used. And I can click here, this graph, and I immediately see that I have two core abstractions in my library. In this case, it's called ID clonable. As an architect, this is interesting. Abstract base classes, interfaces, these things are very interesting for me. So I am very interested in how this abstraction, ID clonable, is applied in real code. And I immediately see that in the collection area of my application, this abstraction is applied, and I can double click directly from this graph, and let me quickly prove that this really worked. Here I am directly in the source code, and as an architect I can now take a look at whether this abstraction ID clonable was applied correctly, and maybe I have to check with the developers whether this abstraction is applicable or not. So this was the first application where we can use these code maps. You will see the code maps in a second too. But let me now, again, from an architectural view, take a look at the broad application, and let's do a kind of heat map analysis, KPI analysis. Let's go to the AndyPan tool here. We have a lot of things. For instance, I could do a dependency matrix analysis. I only have 12 minutes, so I have to focus, and therefore I would like you to show a heat map. This heat map, in this case, I decided to visualize the methods. The size of the squares is the number of lines of code, how large is the method, and here I see the cyclomatic complexity, which is indicated by the color. So this one might be interested. This is a reasonably large icon, so this is a large function, and it's complex. So as an architect, I would like to take a look at it to understand whether I should refactor this method. Double click, and again, I'm directly here in the code. Now, before refactoring this code, I might ask myself, hey, if I break something, do I have tests which run this method, things like that? And of course, we can analyze that, and we can apply again the code map feature. So let me quickly bring up the code map again and ask Visual Studio, hey, you know what? Show me this method on the code map. And it shows me this method, and I can follow the link, and you see, oh, there is a link from the testing DLL. Let's drill into it, and here, oh, I see there is a test which is called merge. Let's take a look whether we find this test. Here it is, double click, and you see here, now I have the test. I now understand that the complex method that I would like to refactor is protected by unit tests, and I can immediately right click here, run these tests, debug these tests, focus live unit testing on this test method, so I'm really protected when refactoring this part of the code. Now, last but not least, in the last 2 minutes or so, I would like to view the tooling that I would like to show you today from the point of view of the quality engineer. The quality engineer might not be that deep into Visual Studio. Maybe she is, that's possible, but let's assume the quality engineer would like to focus more on the quality side of the thing. And here I would like to demonstrate today the integration of SonarQube. I guess many of you are using SonarQube, and we're the provider of C#, and therefore I would like to show you how this is nicely integrated. We're using Azure DevOps, here the live portal, where we integrated SonarQube directly in our build process. This is a build process running in our Azure cloud and building the Google ProtoBuf engine, doing all the analyzing and publishing the data into a SonarQube server, which I, of course, run in the Azure cloud. We can, for instance, integrate our tools. Here you see the VS Test Runner code coverage. This code coverage runs directly, although everything is running in the cloud, directly into our SonarQube server. So let's take a look at the SonarQube server. Oh, let me show you before. If we go to builds, we can take a look at some build results directly here within Visual Studio. If I open up the build here, you see things like code coverage analysis or test results and things like that. But now the tester, the quality engineer, would like to see some KPIs. And we were asked, what is the quality status of this library? And as you can see it here, a lot of green dots here, a lot of A's. So this library has very high quality. And as the quality engineer, I can now use the tools of SonarQube, for instance, to do an analysis. For instance, here I see the coverage versus cyclomatic complexity. And again, I can drill down and analyze why we don't have tests. Or I can go back to the issues, take a look at the code smells, and if I click here, you see that I don't need Visual Studio to immediately see the code and my code smells detected by the C# compiler. So with that, we have, last slide, a platform consisting of Visual Studio and the Azure DevOps platform. We have a lot of tools built into our IDE and built into our cloud systems. And on top, I showed you 2 partner systems, only 2 out of many, many partner solutions, which have chosen the Visual Studio and Azure DevOps platform to sit on top. And so we can fulfill a lot of interesting tasks for the developers, the quality engineers, and the software architects. I hope it was interesting. Thank you for listening to me. I hope you liked the presentation. Thank you.
Thank you very much, Microsoft. Thank you very much.